Please give a warm BC Natural Resources Forum welcome to Kylie Williams, Regional Director, British Columbia, BC Net Zero Innovation Network, and Foresight Canada. Let's hear it for Kylie.
At Foresight Canada, we're helping the world do more with less sustainably. As you said, I'm Kylie Williams, Regional Director for British Columbia, and I lead the BC Net Zero Innovation Network. Our mission is to accelerate the adoption of clean technology solutions to make BC's critical industries economically and environmentally sustainable. A clear message that I've heard this week is that we need to cooperate in the face of change, and we need to do it very quickly. As Minister Dick said this morning, fewer words, more action, more achievement. At Foresight, we're rallying change makers to reduce our human impact on climate change while fostering economic growth and, another term from the Minister's breakfast, diversification. It is now my pleasure to introduce Sue Paish, CEO at Digital, to moderate the next panel, exploring biomining's role in sustainable resource development. Thank you very much, and over to you.
Terrific. Thank you, and welcome. We can't see how many of you are out there, but we're assuming it's close to 400. So if you don't have a seat, there are a couple up here. Thank you for coming to this session where we're going to talk about biomining. And over the last couple of days, as we've listened to the presentations from speakers and panels, there's been some key themes of prosperity, speed, collaboration, innovation, results. And these are all the same terms that apply to our mining sector right now. And they're the same terms that apply to biomining. Biomining, the new approach to a sustainable mining sector, a sector that, as we all know, provides hundreds of thousands of jobs across the country and billions of revenue for GDP and export revenue. And we have a challenge. We've had a challenge with our mining sector for the past many years. Extraction processes and mine remediation processes have used chemicals and other products that are damaging to the environment and actually threaten the overall sustainability of the industry. Enter MMAP, the Mining Microbiome Analytics Platform. It's a mouthful, but our panel today is going to describe how this project, a project that involves 8 organizations across the province, has changed the future of mining for Canada and the future of mining for the world. It's the largest investment in biomining in the history of the sector. So without further ado, I'm going to turn over to my panel here and ask each of you, Mike, I'm going to start with you actually, given you're closest here, and ask each of you to introduce yourselves and talk a little bit about biomining.
Great, thank you, Sue, and thank you to our hosts. I've been here since Tuesday, and it's always been an interest of mine to come to Prince George, which I know some of you might think is odd, but as an undergraduate student in forestry, I always heard great stories about what was going on in the forest community in Prince George, so it's great to finally be here. I am the CEO of a company called MMAP Technologies, and I recently inherited this company, which started as a scientific project between Teck Resources, Rio Tinto, UBC, Alonia, BGC Engineering, and Kunki. And with these shareholders comes a great opportunity to advance new technologies at the microbial scale. And we probably could spend most of the panel just getting into the jargon here, but when I talk about microbes, I want you all to think about, like in our gut, we have tiny cellular organisms that do all kinds of really cool functions. What we rely on for carbon sequestration in soils, or what we rely on for phosphorus or nitrogen uptake, are all microbial processes that are happening at the very micro scale. And what we now have, because of the tremendous investment and created by public and private partnership, is Canada has a world-leading database and data pipelines to be able to peer at the micro scale like we never have before. For many of you in forestry, this is like the beginning of satellite imagery, but at the inverse scale. And so I'm here hoping that many of you out there that are working in various stages of mining understand that we now have at our disposal tools for diagnosing what can help us have lighter impact at the exploration level, during projects, dealing with tailings ponds and toxic contaminated sites. All of that can be helped and managed through biological engineering, but knowing what is there and what their kit of parts is to work with comes from MMAP. And it's an exciting opportunity to be leading the first company of its kind, essentially a eDNA biotechnology company. So excited to learn.
Thanks, Mike, and we're going to dig a little bit more into the MMAP organization as we get into this. Charles, how about introduction and talk to us a little bit of your perspective on biomining.
Thank you. Thank you. Again, thank you for being so welcoming to the people of Prince George and the rest of the province. I'm actually a resident out of Ontario, Sudbury, Ontario, for anybody who knows where that is. My role in the mining industry here is I'm the Vice President for Business Development with an organization called the Center for Excellence in Mining Innovation. And I also play a role in another entity, which is a program called the Mining Innovation Commercialization Accelerator. And the reason why I wanted just to maybe mention those two names is that we are in the business of accelerating innovation into the mining industry. Look, the world needs more minerals and metals. We know this. Everyone else in the world wants what you have. You know, they want microwaves, stoves, fridges, washing machines, and drying machines. You know, I asked my peers the other day, how many of you do your laundry by hand? Very few, right? Now imagine if the rest of the world becomes like us, where we have all these things, vacuum machines, vacuum cleaners, where we have these little tools that we use to do everything. It means we need more minerals and metals. I'm not even talking about the EVs that are needed or the buildings that need the steel. Just to have the household things that everyone else has is going to demand more minerals and metals. But here's where MMAP comes in. We simply can't mine as usual. We can't use dirty mining techniques to produce clean technologies. So MMAP is offering us ways to extract resources from those host rocks, to extract minerals and metals, using things that nature has already provided. We don't have to invent these microbes. They're already here. It's a matter of just identifying what these microbes are. These, I like to call them rock-eating bacteria. You know, we need to just find them, classify them, which is what MMAP is doing. And once we classify them, put them into libraries. When the need comes up, we go into our libraries and find the ones that best work, scale them up using some other techniques. But I'm very, very excited to be able to say that the future of mining is not only clean and green, but the future of mining is going to be using technologies that are actually already created by nature. And these technologies are in the form of these little robotic things that are called microbes, and they can extract value. They can also clean the effluent that's out there and do a whole lot more. But I'm not going to speak too much about that for now. Talk about it later on. And over to you.
Suzanne.
Yes, so I'm here because we are embarking on the new frontier for sustainable mining. And it does require new innovation and new ways of collaboration among different partners. I'm with Genome British Columbia, and we exist to invest in world-class research, genomics research, and innovations that are targeting some pretty significant challenges facing human health, first and foremost, and the resource sector. And we are known for our work in precision medicine, tracking those COVID variants, personalizing your treatment for cancer, and we export everything we've learned in that clinical environment to address how to breed in forestry trees that are adaptive to climate change, how to tackle water quality issues when, in tailings, as well as contaminated sites, and how do you ensure that you have a healthy environment for the future. So everything that we do around the genome, and we can get into that a little bit later, we can also apply to any biological system, including mining, energy, and the environmental sectors. And for Genome BC, we've put in almost $1 billion over 25 years, and about 30% of our portfolio, that's almost 400 million, has gone into this sort of the resource sector space.
Thank you. So now you might have a little bit better sense about what biomining is. In a non-scientific terminology, I call it sort of bugs and fungus and other kinds of naturally occurring organisms to do the work that chemicals and other deleterious products used to do over generations. And you've heard a little bit about this concept or this idea called MMAP. And MMAP is a technology, and Mike, you're going to get into it a little bit later, that has come together because 8 organizations, and I'm going to read their names in a minute, I don't have them memorized, but 8 organizations came together to say, we think we can solve this problem of making sure that our mining sector is more sustainable. And we can do it together by working collaboratively and listening to each other's perspectives. So the organizations around the table, in addition to the 3 we have here, are Tech, Alonia, BCG Engineering, Center for Excellence in Mining, that's with Charles here, Klunkey Cloud Services you've mentioned, UBC, Genome BC, and Rio Tinto. And you might hear the bookends there. We've got Rio Tinto and Tech working collaboratively on a solution, when in the industry, maybe they may be a little bit more competitive. So the idea here is let's get organizations that might not normally sit at a table together. Let's get them around a table together and get them to listen to each other's perspective on this problem of the challenge that we have in creating and moving our mining sector to be more sustainable, and see what we come up with. And that's the kind of work that digital does, is we bring organizations that might not normally sit together to a table where they can discuss the issue, identify the problems, and then come up with a solution that's better than any one of them could have produced on their own. So that's the framing of the MMAP project, and Mike's going to speak a little bit more about it. But I want to talk I want to hear a little bit from you, Suzanne, on Genome BC. Now, you've mentioned it in your introduction there, but most of us, when we hear Genome BC, we do think about health and life sciences. We think about the Human Genome Project, and we think about all the work that you're doing in cancer and in other areas by using genomics research. So how did Genome BC get excited about biomining?
Thanks, Sue. Yeah, so I'll just maybe just go back to some of the basics. So genomics really is the study of DNA, not only what it is, but how it interacts with the environment. And that is really about, the field of genomics is about understanding on a molecular level everything in biology. We sequenced the human genome, finished it 20 years ago, took 13 years, $3 billion. In mid-2000, someone was able to get their genome sequence and the sequence of their tumor done for about $250,000, $500,000. You can do it today, a couple of hours, a couple $1,000, or maybe cheaper depending on what quality you want. That's why we're here. We've been armed with an incredible explosive field of discovery since completing the human genome. That's partly why we exist for BC and for Canada as an organization. And it is an unprecedented part of unlocking opportunities for new discoveries. And it is directly correlated to the foundational work of MMAP. And I really would describe MMAP is really like the drug discovery process we would use for human health, but it is for the environment. You need to understand the basics of the biology and the biological systems, the little bugs that are doing all the work in the environment on these mine sites, in order to then take it to the next step, and we can kind of get into the details there. But that's really what the opportunity is and why I'm excited about it. And it is about using these microbes for, as I mentioned, improving water quality. Bugs eat everything. They'll eat toxic compounds. They don't technically eat them. I'm sure Charles or Mike can correct me. But what it does is it makes it more, makes it easier for us to, as engineers perhaps, or scientists, take it out of a liquid environment or a different environment and capture it and then change it into a different component that we are then able to treat more effectively. So that's why I'm here and for Genome BC, and it is the future, and I think everything we learn in human health, and there's lots there, is going to just explode in terms of its opportunities around tackling some pretty nasty environmental impacts. Legacy mines would be one on the top of the list. But also, if you want to accelerate, the clean energy transition. We need to find ways of doing this sort of industry growth in a sustainable way. The issues remain the same. We need to scale new innovations to tackle some of these tough problems.
Thank you. And Mike, I'm going to ask you to slipstream behind that, because we've now heard the role of genomes and genomics in mining, so we've got that clear. You've been at the coalface, no pun intended, since MMAP began. So talk to us about what MMAP is, how did it come together, and why are you now part of this new organization that's been spawned by the project?
Okay, thank you, Sue. So anyone that looks at my hands can tell I've never actually been close to a coalface. But being at the start of this industry is super exciting. So in a nutshell, as Suzanne was mentioning, DNA is everywhere. And what we know about the Earth's DNA is a fraction of what's actually out there. But we're starting to know 10 to 15% of that stuff that's really critical and important to us. And so MMAP was brought together as an industry academic coalition consortium to solve this problem, because no one organization had the disciplines in-house, had the expertise, and so it was really a cross-disciplinary approach where both money was exchanged hands and in-kind contribution from all of the partners, with the intention that this was not going to be owned by one entity or the other. It was too valuable as a public resource. And so the journey of MMAP started, and which is not one for the faint of heart for any of you that have done a lot of academic industry partnerships, is getting that partnership to work well is one thing. Getting outcomes that industry is happy with from an academic partnership is always another. Getting the outcomes that the academic wants from the partnership is another. But then to be able to do that, to build something that is greater than the collective effort is not always done, and I've seen lots of failures being at the interface of academia and industry. But with MMAP, it was this acknowledgement that from the start of the mining process of exploration, whether we want to understand proper ecological baselines, there's been a lot of talk about environmental impact assessments. This should be a fundamental tool to any environmental scientist or ecologist that wants to understand baseline conditions of a site through a soil sample. Then we can get the array of life that exists. But if we're looking for very specific things like copper, there's combinations of microorganisms classified as CUP. So by concentrations of that, those combinations of microbes, we know that there is sufficient copper in that deposit. We can't tell quantities, but we can start to get indications without massive amounts of drilling programs. In tailings ponds, in pit lakes, there are metals and minerals that are sitting there that we can't capture. Microbes can be put into these using natural occurring microbes. We're not talking about synthetic biology, I want to be clear. We're talking about natural occurring microbes that are put into these toxic contaminated sites that can bring the metals and minerals together, drop them to the bottom, and help us start to treat some of the complexity of what these post-production sites have created. And then finally, long-term measurement and verification, whether we're trying to validate biodiversity or the carbon market and the potential unintended consequences of carbon offsets, for example. It's the story of the health of the environment is in the microbes. And so if we're looking to make soils more productive, we need to look at the microbes. If we're looking to turn off some toxic chemicals or toxic process, chances are there's a biological solution to it. And I mean, it feels, for me, I've been in the startup community for a long time. I've been an entrepreneur for over 15 years. And working with MMAP feels a little bit like drinking from a fire hose in terms of where do you point the opportunity first? Where is the most critical, important solution development that needs to be had? And if you go look online, you'll start to see companies emerging all over the place. Vancouver has Tursa, Endolith in Calgary, Aloni in Boston. These are companies raising massive amounts of money, like we would see in a pharmaceutical sector, to solve these mining-related problems. And I think Canada, particularly British Columbia, is sitting on a literal gold mine here.
So let's just pick up on that, Charles, because you, in your role, you actually look at the broad spectrum of the mining sector, both domestically and globally. So just slipstreaming behind what Mike's just dangled here, what is the global opportunity, and what were the opportunities, and what are the risks and threats we need to be alive to? Because Canada's history in a lot of innovation is we kind of think small and we kind of think local. And here now, it sounds like we've got a platform that has global relevance and a potential to not just transform the domestic mining sector, but potentially transform the mining sector, period, globally. So how do you see this through your lens with the global perspective, the impact and the opportunity for Canada?
Yeah, like I think globally, communities are starting to challenge the mining industry to say, if we give you permission to mine in our backyard, how are you going to preserve our water? You know, how are you going to make sure mining is not impacting our agriculture, right? And the answer back to the mining industry, to the communities, is we are going to find the technologies that are going to allow us to perform mining in your backyard in a way that preserves your environment, that doesn't destroy your water quality. El Salvador, as an example, you know, recently lifted a national ban on mining, but the community is still complaining, saying, hey, if all the mines are upstream and all the communities are downstream, we don't want to drink contaminated water. So how do we answer the question? This is, I think, where MMAP comes in, where we say, made in Canada technologies are going to be instrumental in transforming the global mining industry. Canada is already trusted globally. People actually trust Canadian mining. We're known for our safe mining practices and also known for our responsible mining practices. Canada actually stands to globally dominate the field of mining technology. Above all the other industries, here's an industry area where we can actually be dominant. MMAP is going to allow startups to spawn from Canada that are going to address all these mining needs. You know, as Mike was saying, all the way from prospecting, exploration, permitting, you know, and how we design and construct new mines, do the extraction, mineral processing, you know, how we actually take care of the tailings and how we restore back that land that we touched to its natural state or better. All this is going to be enabled by us embracing these technologies. I think Canada's threat, at least maybe what we should be aware of in Canada, is that if we're not careful, someone else is going to take these opportunities and monetize them. And this has happened in many areas. You know, even when you look at the AI, for example, AI, machine learning, most of it came out of the University of Toronto area, but it's being monetized by ChatGPTs in the States and others like that. But in this area of biomining, you know, it's an area right now where we as Canadians are actually leading the pack. So here's an area where with more investment in those startups that are going to implement biomining technologies, this is how we can win. So if we're going to convince communities to have mining happen in their backyards, we need to bring the technologies that are clean, green, and that are using these natural ways of extracting value out of the ground. These microbes, as Mike said, are in literally every mining operator's backyard. It's a matter of us being able to go out there to resource sequencing, doing the sampling, sequencing, and putting all the information about what these different bugs can do into a database so that when mining opportunities come up, you can quickly go and draw on these different mechanisms that are identified in these databases that MMAP has.
And so we have, it sounds like we have magic in a bottle here, and the opportunity is to make sure that we as Canadians keep ownership of the magic and make it available to the rest of the world. And I'm going to go to one of the questions on the screen here. I think it's question 2. No, it's question 1 now. What's the current uptake of MMAP in BC, and what's needed to make it more commercially viable? And Mike, maybe you can kick off there, given you're right in there. And then Suzanne, with the genomics being a global initiative, we'll go to you next. So Mike, just on question 1 there.
Yeah, so the current uptake in MMAP's database are a few thousand samples from BC mining sites that are managed by Teck and Rio. And the uptake is growing. That's on the mining side. We have also had interest from a lot of indigenous communities that want to use the same technology for eDNA barcoding and baselining, as I mentioned, of what is available on those lands. What are the microorganisms that are there pre-construction, and then using this type of technology to trace where contaminants and others might be moving through a watershed. And so the company was basically in a research mode up until about 3 months ago. So we have been overswamped in the demand from just our existing partners. But I do think that, and as I mentioned, this is the place where a lot of uptake from this technology is going to be valuable and be put to a lot of good use.
And just pulling on that string a little bit, and Suzanne, coming to you, that's on the positive side. There's a question in here. They keep jumping around on me here. There's one here that talks about how do you make sure it doesn't hurt the mining sector. So how do we know we're not, so it's fourth one down, how do we know we're not introducing invasive pest bacteria, bugs that could take over the ecosystem they're introduced to? So Suzanne, can you speak a little bit to that? Then we'll come back, Mike, to you a little bit as well. How do you make sure that when you're in this science domain that you're doing science for good?
Yeah, so I think that's maybe a broader question. You know, when you're doing first of all, you have discovery-oriented research that takes place in the post-secondary, in the lab benches in the universities, and then you want to test it out in the lab. Then you want to pilot it somewhere. Typically, what I think Mike was talking to in these closed systems, or if you want to, one approach is using these bioreactors and certain communities of microbes that you are containing. And you need to work with not only the policymakers and the regulators to ensure that you are doing that pilot field trial in the appropriate environment. So that requires, to your comments, Sue, around having the right folks around the table when you're embarking on these large-scale initiatives that are leading to a new product or innovation that is going to hopefully go to market, help some small companies grow, but also solve some difficult problems. So it does mean you need to convene not only the scientists from the academic side, the industries and their challenges to design the product fit for market, but you need the government folks that are there as well. So that's sort of on the trajectory of that. I mean, I did want to just add to the other comment around the opportunity for MMAP, and it is foundational. And Mike talked about, this is sort of the first platform, and it's a very unique, large-scale, multinational, 16 million or something and change. It's very significant to have competitive companies coming together, but it's the biological problems that the mining sector is facing that is coming together with the tech sector, the software sector, and the physicists, software engineers. So it's a really multidisciplinary team that is going to create a foundation for future inventions and future growth. And Mike, you mentioned sort of environmental DNA. So there's lots of work that goes on sort of in genomics and biology to solve these, but the scale of MMAP is very unique. And it's a scale beyond that we've typically seen, particularly at this point in time. But you would fund something like an iTrack project that involves a couple of First Nations communities. It is across Canada, BC, and Quebec. It's a couple $1 million, but it is on the road to set new standards. So again, that's an example of trying to work with the regulators and those that set standards to replace an environmental assessment process with some new tools. So you're doing real-time sampling with new technologies, presence or absence of a species. You can benchmark changes in the environment. Maybe the environmental assessment process becomes a real-time thing rather than a 18-year journey. Anyway, just to comment on that.
If I can just add to that quickly.
Please.
Look, when a new mine is about to open, the people that invest in a new mine want to invest knowing that the technologies you're using are actually going to work, right? So one of our challenges, and I think it's an opportunity, is that any of the technologies that are coming out that are biotechnology related or that are biomining related, we need to rapidly test these technologies and validate them so that the new greenfield sites that are going to open for those new mines that are opening in your backyards can start to take in some of these technologies. So we do need those investments to happen to fast track commercialization, proof of concept of these biomining technologies so that they can become commercially viable and commercially utilized in the industry.
So I'm going to go in a different direction here. We've got bookend questions on the screen, the first one and the bottom one there, that both talk about the inclusion of our Indigenous communities in this kind of research and this kind of initiative. So again, Mike, I'm going to come to you first. You being heavily involved at the front end and throughout. Let's bucket both of those questions together, which really come down to our Indigenous peoples are the ones that have stewarded these lands for generations. We arrived and mucked it up, and how do we make sure that our Indigenous communities are involved going forward on MMAP and similar initiatives?
Yeah, great. Thank you for that question. And I think the most clear way that Indigenous people can get engaged with this tool and take the most advantage of it is around gaining inventory of what is on their lands. So I'll use an example. I had the opportunity to spend time in Tahltan territory last summer with an elder, Jerry Asp, and got to go visit a number of sites throughout the region. And there are areas where elders will say, there were caribou here. There were caribou here, but we're not seeing them. We're not seeing sign of them. We will know in the microbes if there was caribou there. And so that's one example of really being able to get accurate information about the makeup of very significant sites for future inventory, for future conservation, target, and protection, because we will find microbes in certain places that exist nowhere else. And I think having more people on the land and having this type of technology that is easily available to anybody with an envelope and a shovel means that we can start to use this type of tool in a way that right now we think we're going to use it to solve a lot of mining cleanup problems. We also think we're going to use it in agriculture to enhance soil uptake of nutrients. But there are going to be other ways of being able to view the world in a way that we've never been able to view it before that is going to unlock things that we've not even thought about yet. And I think if companies are hesitant about engaging in innovation programs like this, what I can say is that any investment they're making in further understanding what is on their site is basically mitigating a future liability. You don't need to worry about, okay, don't look because I don't want to know. It's everything that you want to know about that site from a biological perspective can be put in front of you on a dashboard, and all of the fungi and the bacteria and the flora and the fauna that exist. So I think that's the first and easiest way. But the next way is being guardians of landscapes and watersheds. So if we think there are contaminants moving through the watershed, we can find that out without expensive geochemical testing and treatments. So I could go on.
I know you could.
Yes.
And we could probably listen to you. But I'm gonna let Charles and Suzanne. I'm mindful of the time here. Charles and Suzanne to sort of bring us home a little bit on two-pronged here, continuing with the comments around inclusivity, and you've seen it, Charles, probably on a national and international scale. How do we make sure that we include our Indigenous land stewards and our Indigenous citizens in this kind of initiative? And I'm going to slip in another question there because we're going to be short of time. Where's it going? Where are we going with MMAP?
Gotcha, yeah.
Charles and then Suzanne.
Yeah, look, Canada actually has thousands of abandoned mines out there. I mean, it's actually sad to think that we do, but we do. So these thousands of abandoned mines that are out there in the communities, some of those are actually on Indigenous lands. And most Indigenous communities don't really want new mining to happen before you clean up the mess that's already on the ground. I think that's where MMAP can come in, you know, where over the years that these mines have been abandoned, these little bugs, microbes, have already started chewing away at what has been left behind. So as Mike said, you know, if you get a sample of the land that is contaminated or has an abandoned mine on it, it can actually give the scientists enough knowledge to know which microbial species are actually existing there, that if we then scale those up and increase their numbers and then bring them back to the site, we can see a rapid cleaning of those sites using the greenest technologies that you can find on the planet. In fact, MMAP has got the greenest technology on the planet. It is as green as you can get it, right? It's straight from Mother Nature. So I think that's where MMAP is going. So MMAP is going to, I think, be the fundamental platform to issue a new era of mining where we're going to be able to stand up and say, mining is not a dirty industry. Mining is a clean industry that produces clean minerals and metals that are going to power this transition that we must go through as a species.
And Suzanne, how do we be more inclusive as we possibly can, and where are we going?
Yeah, no, thank you. And we have to do things differently now. It's the new imperative. It's the right thing to do, and there's huge benefits. So, Genome BC, obviously, when we look at designing where our investment is going, we have a pretty open conversation now around what does it mean to design an investment program in the resource sector, or for mining, or for human health, for that matter, or any area in terms of marginalized groups, Indigenous communities, particularly when it comes to the resource sector. It's no question when you're dealing with new technologies at the forefront of innovation, there are risks with those that don't have access to it first. That's the reality. So the important thing as funders, and digital does this too, is that how do you ensure that there's awareness, education, inclusive vehicles for participation in the research and in the development of that technology as it makes its way into a new company or perhaps public adoption. And that's a commitment from Genome BC. We've invested in our own capacity internally, and we commit to capacity building, education awareness for, in the case of the environment and mining sector, if there's nations that want to sequence and sample and sequence on site to have informed decisions, they can do that, and we'll help them with that. And I know digital does similar work around digital technologies, but that is the gap that is at risk with new technologies, and as a funder, we're committed to that. Where MMAP is going, I can't say it now, but there's going to be new news next week around offshoots from this platform. But it is, if you can figure out what areas to target for these new therapeutics for your problem, then you design an investment program around trying to find out, okay, let's tweak the function of that community of microbes under the right conditions so I can really, truly sequester selenium out of that water, or clean up that toxic compound that is left in my soil through other vehicles. So that's the future. It's these functional genomics use cases that are going to come out of this platform, and that'll fuel the company and companies, actually.
So I know we could stay up here all afternoon. There's a lot to talk about. We've got a lot of questions, but the red light's flashing. I'm going to get in a lot of trouble here. So here's the takeaway. Canada has done something incredible here. Canada has brought organizations together, 8 of them, that wouldn't normally sit at a table together, that wouldn't normally sit down and say, how can we solve a significant problem that could affect one of our most important industries? And together they've come up with a solution that is truly better, that they've done together, than any one of them could on their own. And we've got it sitting right here for us. And so I'm hoping that next year or the year after, and there's a question here about uptake, we will come back to you and we'll be able to report on how we've moved this with speed to deploy across Canada, across British Columbia, and truly across the world, so that Canada can once again be seen not just as a leader in the mining sector, but as a leader in mining technology in the sustainable mining sector that will allow our minerals to be picked up around the world with more credibility and more trust and more profit than we ever thought imaginable. So thank you, everyone. There's a QR code that's just come up on the screen here, and you can scan it from the screens beside us here, and that'll take you to the link on the digital website. Digital facilitated the development of this project, so it'll take you to the summary on our website about the project and the follow-up. You can do some follow-ups from there. So thank you, Mike. Thank you, Charles. Thank you, Suzanne, and thank you for allowing us to have this conversation.